Okay, so we're going to go through the next couple pages here. We're going to start on the second page of the notes, the one that's got the big graph on it. We're going to go through log graphs. Then we're going to quickly go through common logs and natural logs. So to graph a log function without a calculator, you can't do it unless you use the inverse to help you. So you want to switch your x and y. So it's going to now look like x equals log base b of y. Then you're going to solve for y, so we have to switch that to exponential form. So you're going to have b to the x equals y. And then this next one, I know the line is not very long, so just fill in where you can. So once you've done that, now you want to find points and switch back. So we're going to go ahead and we are going to graph y equals log base 2 of x. So that means that when we graph it, we're actually, to do our first table, we're going to switch our x and y. So we're going to have x equals log base 2 of y. And we're going to change that to exponential form, so it's going to be y equals 2 to the x. And we want to make our table for x and y. And I'm going to write small here because I need to fit it in. So we're going to have negative 2, negative 1, 0, 1, and 2. Sorry, I'm going on to that, I know. So when we plug this in, we'll actually end up with negative 2 to the negative 2 is 1/4, 1/2, 1, 2, and 4. And I know that went on to the next table there, I apologize. So now we want to switch. We want to switch these to go back to our original function. So our x and y that we're going to graph are actually going to be 1/4 and negative 2. It's going to be 1/2 and negative 1. It's going to be 1 and 0. It's going to be 2, 1, and it's going to be 4, 2. So I'm going to go ahead and graph that. Let's get a fine tip here. So we're going to have 1/4 and negative 2, so it's going to be down here somewhere. We're going to have 1/2 and negative 1, 0, 1, 2, 1. Sorry, that's 1, 0, 2, 1, and 4, 2. So we're going to be right out here. And then you're going to go ahead and you're going to sketch your curve in there. And that's not the best curve, but that's okay. And you want to label it, so we want to label this y equals log base 2 of x. If we want to graph the next one, which let me just erase that out so you can see exactly what it is. If we want to graph this next one, y equals log base 1/2 of x, we want to do the same thing. So we're going to have x equals log 1/2 base of y, and then change it to exponential. So it's going to be 1/2 to the x equals y. So again, for our table, if we do negative 2, negative 1, 0, 1, and 2, we'll end up with positive 4, positive 2, 1, and 1/2. So when we switch that, it will be 4, negative 2. It will be 2, negative 1. It'll be 1, 0. And it'll be 1/2 and 1. Sorry, we can make our table there again. So I'm going to graph this one in red now. So we'll have 1, 2, 3, 4, negative 2. We're going to have 2, negative 1, 1, 0, 1/2, and the next one would actually be 1/4, so it would be really close there. And then we want to sketch our graph in. That was really bad. And we want to label this y equals log base 1/2 of x. So a couple characteristics that these share are they all are going to pass through the point 1, 0. Kind of like exponentials pass through 0, 1. The inverse is you switch it so it passes through 1, 0. There's going to be a vertical asymptote. There's going to be a vertical asymptote at the y-axis, which is x equals 0. When b is greater than 1, the graph is going to be increasing, or increases. And when b is between 0 and 1, the graph is going to decrease. And then looking at the graph, you can actually see that the domain of both of those, it goes from 0, not included, so it's a parenthesis, all the way up to infinity. So the x values are from 0 up to infinity, and the range, it actually goes from negative infinity to positive infinity. So that is everything about graphs. The next thing I'm going to go through, I'm going to skip some parts here because they're kind of the same as what we did in the video yesterday. So a log is still an exponent. They're inverses. This is pretty much all the same stuff, so I'm skipping it to save some time here. And we're going to jump down to the bottom of that page where you have this beautiful box here, which says log base 2 of 8 equals 3. So when you change this to exponential form, it's 2 to the third power equals 8. It goes, the 8 and the 3 will switch, so it's 2 to the third power equals 8. Now, the other two things we need to know are that logarithms with base 10 are called common logarithms. And then there's another thing called logarithms with base e, so that number e that we talked about with Euler and exponentials, and those are called natural logarithms. And these both get special notations. So log base 10 is actually written with log x. So you leave the 10 out. If there's no base, it's automatically a 10. And log base e is what that little ln button on your calculator is. So it's ln, the natural log of x. So how are we going to use that, you might ask? Well, that's a great question. So we're actually going to skip that page that has the examples on it because we did some of them already. And we're going to go over to the next page where it says common logarithms are logs with base 10. So if a log is written without a base, it's the common log with base 10. So anytime you see just log x, it means that your base isn't written, but it's automatically a 10. So we want to round answers to the nearest thousandth. So thousandth is going to be 3 decimal places. So what you actually do here is we're taking f of x, so we want f of 532. So that's going to be log of 532. And now this is one that you can actually put right into your calculator. So you would push the log button, 532, close your parentheses, and you would hit enter. And it's as easy as that. And when you do that, you'll notice that it is going to be 2.726. So just plug this in the calculator. You can put a note in calculator. And that's it. That gives you your answer. For example 2, if we want to solve the equation log x equals 1.2, well, we know that our base isn't written, but it's going to be a 10. So now we can switch to exponential form. So this is going to be, if you remember from yesterday, it's log b n e, and that switches into b e n. So in this case, our base is 10. Our number, we don't know, it's x. And our exponent is going to be 1.2. So we switch it to exponential form, and this ends up being 10 to the 1.2 equals x, which again, you can just put this into your calculator using the caret key, and you will end up with x equals about 15.849. Again, this is just in your calculator. This one you do have to do your switch here though. Moving on to natural logarithms. These are when you have your base of e. So your base down at the bottom there is e, and it turns into ln of x. So if we want to calculate h of 7.65 when it's ln of x, we're going to do h of 7.65, which means you're going to do ln of 7.65. And I'm actually not going to calculate that for you right now. I actually want you to do that when you get into class first thing tomorrow. I want you to get out a calculator, plug in ln of 7.65, and round to the thousandths place, which is 3 decimals. But again, it's just put it in your calculator. The last example I'm going to go through with you here is solving again for x, similar to what we just did a second ago. So what I would do first is I would say, okay, well this is ln, so that means it's log base e of x, which is 4.56. And then I would say, okay, now I know my base is that crazy number e. And this is the reason that I've been using a capital E, by the way. My number is going to be x, that's what we're looking for, and my exponent, the capital E, is 4.56. So when I switch this to exponential form, we're plugging it into b exponent equals n. I will end up with e to the 4.56 equals x. And again, this is second ln. So to get this e, you push second, and then push the ln button. And when you plug it in to the calculator, you will end up with about 95.583. So I know I threw quite a bit at you there, but it's not super difficult. It's actually just using the calculator a lot. The graphs, you can even graph those in your calculator and try and find some points if you really needed to. But for natural logs, you need to remember that it is log base e. And for common logs, when it just says log x, you need to know that that's log base 10 of x. So those are two important things from this video. I will see you tomorrow. I want you to plug that other problem in as soon as you get into class, see what you get. We'll go over it, and I will see you tomorrow. Have a great night.